The trend of ionization, you'll see, has the same trend as electromagnetivity, and we have to look at both the atomic radii and electromagnetivity in order to kind of help explain this trend. Okay, so ionization is just the energy that's required to remove an electron from an atom. Okay, so just like as I was speaking in the last video about these atoms up here having the oxidation number of negative because they're more likely to gain electrons, they're least likely to give away electrons. Okay, so it would take a lot of energy, so that's why this is the high end of energy. It would take a lot of energy to take away the electrons from these atoms, okay, compared to down here. Okay, these atoms down here are more likely to give away their electrons, so it's a lot less energy required to take away their electrons. Okay, so as we move up the group, it's going to require more energy to take away the electrons. Okay, so down here, because there's 7 energy levels in these atoms, the electrons are further away from the pole of the protons in the nucleus, so they're more easily taken away. That's why there's less energy compared to up here, like lithium and hydrogen. Okay, because there's only like 1 or 2 energy levels, they're much closer to the nucleus and the pole of that positive proton charge. That makes it harder to strip away those electrons. Okay, so it's going to require more energy than the atoms found down here. Okay, and then just like when we were talking about the atomic radius, as we move across the period, these atoms are going to have less protons than these atoms. Okay, and so because of the larger nucleus, they have a tighter hold on those electrons, which makes it harder, aka needing more energy to pull them away. Okay, so once again, talking about oxidation, these two groups are going to more likely give them away, making them a +1, +2 oxidation. Okay, because they have less protons in their nucleus to hold on to those electrons, especially when we get down here, they have more energy levels. Okay, and then compared to these over here, remember these are going to be your negative ones, so they're more likely to gain electrons. So it would take a lot of energy to give away their electrons.